All right, welcome to The Explainer. Today we're pulling back the curtain on something called capital modeling. We're going to look at how insurance companies try to see the future to make absolutely sure they can pay your claim when you need it most.
So let's just jump right in with the big question, the one these companies grapple with every single day. How do you possibly prepare, financially, for things that are completely uncertain? A massive hurricane, a sudden stock market crash, or even just thousands of small, random events all piling up.
Well, the answer, or at least their best attempt at an answer, is something called a capital model. Now, it's not a real crystal ball, obviously, but it is probably the closest thing the financial world has to one. It's an incredibly sophisticated tool built to try and map out what an insurance finances could look like down the road. At its heart, a capital model is just a massive, super complex financial simulation. Its entire job is to answer one single, absolutely critical question. Do we have enough money, enough capital, to survive a whole range of future shocks and still pay out everything we promised? Okay, so how does it work? Well, any model has to start with the money coming in. We're talking primarily about the premiums that we all pay for our insurance policies, plus whatever money the company makes from investing that cash.
And then, of course, it has to balance all of that against all the money going out. And the biggest chunk of that, no surprise, is paying claims. We're talking everything from a tiny fender bender all the way up to a catastrophic natural disaster. But you also have to factor in all the day-to-day costs of just keeping the lights on.
And that brings us to the whole point of this thing. The number one goal is to make sure that even in the absolute worst-case scenario, the company's capital is strong enough to cover all those outgoings. It's like the ultimate financial fire drill.
Now, this is where it gets really interesting. You might think there's just one way to build this thing, right? Nope. Turns out there are two fundamentally different approaches to building this financial crystal ball.
On one hand, you've got what's called a deterministic model. Just think of it like a simple calculator. You punch in specific numbers, you get one specific answer. That's it. But on the other hand, you have the stochastic model. This is way more like rolling a pair of dice thousands and thousands of times just to see every possible outcome.
So let's dig into that first one, the deterministic model. This whole approach is really about asking very specific what-if questions. The process here is really direct. First, you pick a very specific assumption. Let's say a monster Category 5 hurricane makes a direct hit on Florida. Second, you plug those fixed numbers into the model. And third, out pops a single, clean answer. Something like, okay, the financial hit is going to be $5 billion. Simple as that.
And the bread and butter of this approach is something called stress and scenario testing. A stress test is when you just change one thing, like what if interest rates suddenly spike, to see the impact. A scenario test is when you start combining bad things, like a hurricane and a stock market dip, to see what the combined damage looks like.
Okay, that's all well and good for the risks we can kind of imagine, but what about the risks you haven't even thought of? The unknown unknowns, as they say. For that, you need something way more powerful. And that's where the stochastic model comes into play. So instead of using one fixed number, like claims this year will be exactly $100 million, this model uses a probability distribution. It's a fancy way of saying it considers a whole range of possibilities for that one variable, from a very quiet year to an absolutely disastrous one, and it assigns a likelihood to each of those outcomes.
Now here's the wild part. The model then runs a simulation, picking a random outcome for every single variable from all those possibilities. But it doesn't just do it once. It does it again and again and again, often more than 50,000 times, to build this incredible panoramic picture of all the possible financial futures the company could face.
So you can see the choice insurers have to make. You've got the fast, clear, but maybe limited model on one side, and the complex, comprehensive, but much slower one on the other. And honestly, which one they use really just depends on the exact question they're trying to answer. And this chart just lays out the trade-offs perfectly. Deterministic models, they're fast, they're simple, and they are fantastic for giving a clear answer to a direct question from the board. But stochastic models, they are absolutely unmatched when you need to explore the entire universe of possibilities and uncover those weird, unexpected ripple effects. But let's be real for a second. A model is just that, a model. It's a simplification of reality, and it's only useful if it's actually accurate. So how do you make sure your crystal ball isn't cracked? Well, you test it, rigorously. They start with those same tools we saw before, but they use them for a different reason. They use stress tests not just for a what if, but to check if the model's reaction is sensible. If they tweak one isolated variable, does the model's output feel right? Does it align with how they understand the business in the real world?
Next, they use scenario testing to see if the model behaves realistically when lots of things go wrong at once. Does it capture those complex knock-on effects that cause the biggest headaches in reality, or does it miss something critical? It's all about checking for believability when the pressure is on.
And maybe most important of all, they do something called back testing. Think of this like a report card for the model. They take historical data from the past, run it through the model, and then compare the model's predictions with what actually happened. If they don't line up, it's back to the drawing board to refine the model.
And this really brings us to the final, critical question here. All of these powerful models, both the simple and the complex ones, are ultimately built on data from the past to predict the future. So in a world that is changing faster and faster, facing totally new kinds of risks, how in the world do you model a future that has no precedent?